Welcome, everybody, to day 2 of CppCon. We have a great fireside chat panel again this year with folks from the committee. Some of you have seen on these panels before and some new faces as well. And many of the questions that we're going to talk about actually have already had pointers to this panel from yesterday in the Q&A sessions that we've had. So we look forward to spending the next hour or so with our panelists who are participants and often leaders in different parts of our standards committee and international process as we talk with panelists live from many time zones in 3 different continents. So thank you all for making yourselves available. As we go through and introduce each of you, perhaps you can say something brief about what you're currently doing in C++. Certainly, Bjarne, you need no introduction. Everybody knows who you are, and thank you. You're the reason that we're here and having this conference. And I know that working at Morgan Stanley, you also work at Columbia and doing teaching, as well as using C++ in demanding environments at the bank. And so we also appreciate that you're still part of C++ standardization. So I don't know where you find the hours in the day, but thank you for that. Let's now introduce also some of our other panelists. JC Vanwinkle, you chair the tooling group. Tell us a little bit about what you do at Google.
The study group, actually. The study group about education, actually.
Education,
what I do at Google, I'm the co-founder and lead educator of a group of people called SRE EDU. We educate our new hires who are going to be site reliability engineers, and also we try to organize continuous education for all the people who have been at Google longer.
Excellent. And Hana Duzakova, who was our host of our most recent and hopefully not last face-to-face meeting in the Czech Republic, you chair the Compile Time Programming Group. Tell us a little bit about what you do.
I'm doing mostly sharing, so it's making sure people will finish their papers, and I push them to do something more and hopefully get a reflection in 23.
Very nice. Bryce, you are now the chair of the Library Evolution Working Group, and at NVIDIA, tell us a bit about your work in C++ and how it relates to standardization.
So I at NVIDIA, I lead our C++ standard library team, and I work on programming languages and standardization. So not just C++, but also Fortran and C. And in addition to being the chair of Library Evolution, I serve as the chair of the U.S. National Standard Body for Programming Languages. Yeah.
Definitely a busy person. So thanks for making time for us. Michael, and sorry if I get these out of order, the names are jumping around. Michael Wong, you are running several SGs, including the real-time and low-latency gaming SG, as well as the new AI one. Tell us a bit about what you do and how it relates to standardization.
Well, thanks, Herb. So I'm a distinguished engineer at CodePlay. And what I'm doing is mostly doing research in the area of programming models, especially relating to heterogeneous programming, AI, and machine learning, which is related to my SG, as well as safety critical models, which is related to my other SG. So it all leverage very nicely.
Very nice. Now, Inbol Levy, you're the head of delegation. You're the chair of one of our newest national bodies, the Israel C++ National Standards Body. And so you've been attending for a few meetings now. Tell us a bit about what you do in C++ and your interest in standardization.
Sure. Thank you, Herb. So first of all, I want to say that I'm very excited to be here today. And yes, I think we're the newest national body. We joined around almost a year ago, I think. And I'm an embedded developer, but I have to say that I'm really enthusiastic about what happens in the community. And I think that a lot of issues are being addressed, and this is very, very interesting to see C++ getting evolved. So thank you.
Very nice. And JF Bastian, who's now our Language Evolution Working Group Chair. Tell us a bit about yourself and your work.
Yes, so I'm JF. So I newly chaired the Evolution Working Group. So, trying to advance the language forward in a responsible manner. adding interesting features and things like that, and fixing old bugs. So that's the main thing that the group ends up doing, right? Like looking at kind of big features and things like that. So you know, work-wise, I've focused on security quite a bit in the last few years. I've done a lot of compiler-related stuff and things like that. And I'm starting a new role soon at Toyota Research Institute Advanced Development, working mostly on automotive and mobility vehicles. So doing stuff related to standards and safety as well as reliability.
Thank you. It's nice to see that to help everybody see our panel involves everybody working from AI to automotive, safety critical to teaching. That's important. And finally, last but not least, Tony Vanair, who has been a longtime expert in C++. What's your one sentence, what you're doing these days and how it relates to standardization?
Yeah, I work at Christie Digital. We make projectors. I do what's called projection mapping, where you take a bunch of projectors and seamlessly turn it into one giant image on the side of a building or 3D object, whatever. On the committee, I'm the person here who's not a chair of a committee of a subgroup, but I'm the unofficial chair of the naming subgroup. We just don't know what to name the subgroup. That's the joke. And yeah, I just need C++ in my work, and I've always loved the language since way too long, 90s. Yeah.
Thank you, and welcome everyone. Now, because you will be answering the questions and I'm just feeding them to you, you actually don't need to see me. So let me put us in the mood of a fireside chat. And our first question, why didn't C++ die around the year 2000? And why does its use still seem to be growing? Who'd like to take that one?
Well, I wrote about it in my History of Programming Languages paper, so it would be obvious for me to start out. I actually worried more about 2005, which was the nadir, I think. And there was a lot of competition throughout the history of C++. It used to be that everybody had to write data, and at around the middle the early 2000s, there was Java and there was C# and such. And I think the reason C++ survived is that everybody wanted to go higher level and more sort of elegant, and they lost the hardware. They couldn't touch the hardware directly. And the other thing was that the competing languages were corporates, pushed by corporations. You forced people to use Java if you were on Android, to use Objective-C if you were on Apple, C# if you were on Microsoft. And the net effect was that the only thing that worked everywhere and worked well was C++. And so you put a sheen over your C++ applications. And then the hardware stopped getting faster. So performance started mattering more. You could again have a good programmer deliver something that was significantly better than 10 so-so programmers because the hardware didn't save them.
Very nice. Now, our first question that we just got on the floor was, what are the biggest challenges in C++ education at the moment? And what can we do to help other than training our own people? JC, you have a study group about that.
Yes, we do. I think that C++ can look daunting at first when you start learning about C++. I'm Dutch, and there is a Dutch word which I translated to English is called choice stress. There are too many ways to do things separate ways, so that is difficult. What we try to do in the education group is not so much create curricula for learning C++, but actually give guidelines to people who want to create a curriculum, for example, at a university. So you should not start with template meta programming as your first subject, which is obvious, but we try to lay out a roadmap of what order subjects could be discussed in, and also when you take one of these specific topics, what the student outcomes should be. So what should a student be able to do after having attended that specific topic in the series of topics. We also try to influence the committee a bit. Actually, the committee is doing a pretty good job here by itself. But for example, the appearance of Tony tables that we saw after Tony introduced them is really helpful. And Gor Nishaonov also introduced a series of a set of tables that are audience tables, in which it says, this new feature that I'm proposing will be used by the millions of people who will use this specific part.
Great. Anyone else would like to weigh in?
Yeah, I have a comment. I think too many people are trying to show too advanced stuff to people. And we need to have a higher emphasis on sort of the hello world level of code so that people see that they can get started. They go to a conference like ours, and people show them how to do the absolute latest and fanciest using the latest features. And they're sitting in their job or studying. They can't use that compiler, or they don't understand it, and they just try to do a simple program. So I would like to see more Hello World style programs, short articles that get people up and running with different features. I suggest people look at KNR, the most successful book in the history of programming, and guess why it is successful? It's not trying to tell everybody everything.
Yeah, I'm sorry, my connection broke off. But what you see is that a lot of people these days are learning Python because it's so easy to learn. Even my son and my daughter, who do something completely outside of computer science, they learn Python at the university. And it's very intuitive, but I think that modern C++, and especially C++20, allows you to code in a Python-esque style without having to know all the nitty-bitty details. And I think we should teach more of that.
Thank you. So a related question is currently the top upvoted. What parts of the C++ standard do you think are the most misunderstood and where education should focus? Perhaps someone who hasn't commented yet.
I would start.
Yes, Hana.
Okay, from my perspective, it's undefined behavior. It's something scary in background. People don't understand what's going on. They get angry and they want, because they say, it's work on my computer, it's on my processor, it should work, and I don't understand why it's not working. So that's the problem with misunderstood undefined behavior, I would say.
Thank you. And Michael, you had a thought.
Yeah. I think referring back to, just to cover the last two questions, referring back to the issue about teaching C++, I do find that having too many complicated examples being thrown out there is problematic. In the games community, we actually had this huge problem, huge debate, where ranges were shown to the games people in a form that they did not think was useful to them. They could already do the same thing using given the example that was shown, and they started questioning, well, why would we even go that far? And it really was just a choice of example there that wasn't appropriate. And I thought that really illustrates why we need simple examples that really help people. So on this particular question, I should turn. Yeah, sure. The many different parts of C++ that could be better improved for understanding, for education. Definitely, I think what Hana talked about. I think lifetime could be improved. That seems to be constantly coming into question. And the other thing is certainly the area that I cover, things like concurrency and parallelism. We're still trying to we're still exploring and understanding the way people read this to understand how it's being used. And it's not the easiest to reach for many people. So definitely, I think there's place to help them. Maybe that's an area for education focus as well too, because in many education curriculum, they might not focus specifically on the concurrency aspects. And that's an important area that can be built up both from the bottom up and from the top down point of view.
And,
I'll agree with
and I see that
Mike.
The question.
I'll agree with Mike, and then I'll just point out that we are getting a huge number of people who think that unless they build class hierarchies and uses the operator new all over the place, the new operator, I mean, then it's not C++. And that is a very serious mistake, because in that direction lies complexity, slow code, and leaks.
I'd love to jump in.
Go ahead, Inbol.
I just wanted to add regarding this topic that I had a short experience of teaching an undergraduate class for kids and for students. And I think the main power of C++, which is also something that we need to regard, is the fact that it's a system language. And when you learn C++, you need to be aware of the system. I think that might be something that is lacking. And I think that by having a solid ground of system design for students, that will also help understanding the great benefits of C++. Because if you don't understand the difference between compile time and runtime, you will not be able to evaluate it properly. So,
yes.
Thank
you.
Sorry, and then I'm going to try to add a push here for embedded, because the embedded coverage in C++ standard right now desperately needs to be better specified, and there's effort going on in that space. Given how many people are in that embedded, and we have a new embedded track this year, that is definitely something we should help along.
Thank you. Now, this next one, perhaps Tony or Bryce might have a thought about this one. C++ does not have a standard or even de facto logging API. Do we need to do something in the standard to catch up with other frameworks?
I can take this one, Herb. I think that there are a lot of things that we could add to the standard library. And there's a lot of things that exist in other languages standard libraries. But in the C++ standard library, our priorities and the things that belong there is limited to a specific set of like high value things. So essentially the things that I think belong in the standard library are the things that cannot go anywhere else. So there's a few different categories of these things. For example, vocabulary types. You can't really have vocabulary types anywhere other than the standard library, because the whole idea of vocabulary types is that it's a common type that everybody agrees upon. You know, that instead of your library having a string type and my library having a string type and the third person's library having a string type, and then some user who's trying to use all those libraries having to traffic in multiple different string types, you have one string type. Or as it is now, you have one string interface type string view. The next category of things are things that are abstractions around the platform. So something like the concurrency library or file system. You could get a third-party library that could provide an implementation of those facilities for you. But oftentimes you want those facilities that are specific to your platform to be provided by the vendor for your platform. So the person who's providing you with your C++ implementation on your platform is probably going to be best equipped to give you an abstraction of the implementation of the abstractions for their platform. So if I'm on, Microsoft, I want the concurrency facilities that have been designed by the Microsoft engineers and designed to work well with MSVC. And the next category of things is things that require language support. So standard library facilities that aren't actually really standard library facilities, but are really just extensions of the language. For example, type traits is something that falls into this category. So those three categories of things, I think, are the primary priorities that we have, because those are things that cannot be satisfied by any other library other than the standard library. And so we have to focus on those first as our priorities. And there's so much that we could do, and we still have a lot to do to even satisfy all the things that fall into those categories. Now, something like a login library, that might be nice to have, but the question is it essential? Can we add greater value in having a standard library login facility instead of, say, working to make it easier for people to use third-party libraries so that you can use some awesome third-party login facility? So I think that unlike in other languages, in C++, our focus should be on a really high quality, but focused standard library. But then we should be spending more effort on making it easier to use third-party libraries, which means enabling things like packaging, et cetera.
Package managers come in there. And let me just actually generalize the question a little bit and throw it also to Tony and JF. But besides just logging, what libraries do you think are missing from the standard library? Tony, you had a comment. Yeah,
I agree with I have to agree with Bryce. He's like, chair of one of my subgroups. There's a couple thoughts on logging specifically. On one hand, I've only seen one excellent logger. So if we were to pick a logger, I bet we wouldn't pick the best one, because the best one actually I ever saw was buried inside a BlackBerry, surprisingly. But a good logger actually could use support from the compiler, because you can pre-compile some of the log lines. So it actually might be something where you could do better if it was built into the library or built into the language somewhat, so that because you can pre-process some of the log lines and then do less work at runtime. And the other way you might want to do a logger is along the road of contracts. The contract mechanism that we've been talking about has hooks in to like call somebody when a contract fails. You could do logging in the sense of they're just hooks into you make a call to the logger, but it's not a particular logger, it's the logging interface, and you've installed the logger at the start of your program. Because it would be nice, logging is almost like a vocabulary type, in the fact that if I write a third-party library, how do I log? Right? I want to log in a way that's compatible with whoever's using my third-party library. Me being the third-party library, that sounds confusing, but if I'm writing a library, it's a third party for you. And right now I can't do that. I can't have my library log in any sensible way such that you can find it. So it would be nice to be able to call a standard function that's like, hey, log this. It turns around and calls the installed logger or something like that.
So are you making the case for a logger being a vocabulary type?
Yeah, and it didn't occur to me until I was listening to Bryce. So, I think he was arguing against that idea, but it suddenly made me think, well, maybe it is a good idea. I don't know if it's the most important idea right now. And I did want to add also what Bryce was talking about is having a package manager would go a long way towards, or something like a package manager, or somehow helping to solve the problem of making it easier to use third-party libraries. But it does occur to me that a logging thing is, it is a vocabulary type. You need to log from everywhere in your program. And it's actually one of those things that's hard to get, it's hard to write a logger in the sense of you want a logger that works even during startup and works in all these strange cases. It's not an easy thing to do. So maybe it is something that we should consider.
It's interesting that you said it's maybe not one of the important things, because that relates to another question which relates to language evolution. So let me throw it, language and library, but let me throw it to JF. It's of the bold plan for C++ 23, reflection, pattern matching, contracts executors. What should we expect, especially now with COVID, slowing down the rate at which we can do work?
I think the way we view things, as we schedule them, as we discuss them, is we're trying to advance the big items, right? So that bold plan is really useful because it tells us, well, here's the priorities, right? And in the bold plan, the top priority is actually fixing bugs right now, right? And so as we've transitioned to this new virtual reality here of working remotely, we have weekly meetings, but what we do is we try to focus on things that are fixing bugs, because we as a group haven't really learned how to work remotely as well, right? It's a bit difficult, and big features are hard to do remotely, right? Like there's institutional knowledge for us of how to work in person. It's much easier, higher bandwidth and things like that. And you can focus on the big features. Now, it happened that the bold plan was written and approved before this whole pandemic, and we had already decided to try to improve the pain points in C++, go and look at where there's defects that we want to fix and things like that, while at the same time also looking at those top priority items that you outlined. Right. So there's things like reflection and pattern matching on the language side. The way we see it is we'll prioritize it. We'll look at it pretty frequently, make sure that we follow up with the authors. So we have special working groups that work, for example, on pattern matching, and they come back to the language group and tell us where they are, what they're thinking, what it looks like, because they're working on a sample implementation as well. And I think we're not approaching it in the sense of we must ship this in 23. It'd be nice. So we're putting everything we can towards shipping in 23, right? But realistically, it might not happen, right? Like we got to have actual usage experience, and that requires an actual implementation that works well in the next year if we want that to happen, right? So unless we agree on all the design criteria and we're sure that this is the right thing, I would count on none of these being in C++ 23, at least on the language side. And on the library side, there might be other things. Bryce can chime in on that. But on the language side, I would cautiously say we're not going to get anything, but we're trying to get those things in cautiously, right? Like if we can make it, we'll make it, but we're not going to rush to that.
Yeah. Bjorn, you were starting to say something too.
Yes, I had some opinions on logging. Logging would be very nice to have for the reason, especially Tony said. And we have to remember that other languages in the formal sense tend not to have standards. I mean, Java, Python, etc. They don't go through an ISO process and have a formal specification or all of that stuff. Instead, they have good distribution mechanisms. Like Bryce pointed out, we need packaging, distribution, central places for storing things. And that way you can have sort of a basically shootout before something wins and becomes a de facto standard. Now, I don't actually think we need compiler support for logging. We have very good facilities for compile time programming that is getting us there. I have some practical experience with a logger, so this is not total random opinion. So if we could get a decent package manager and distribution system, I predict we would have a logger within a year, because there are several good ones. They tend to be corporate or not that widely available.
Bjorn, while we have you there, the next question is about something that you and I do. And since I'm not on the panel and you are, this is yours. How can we, the audience, help with the C++ core guidelines? Do you need editors, blog posts, people to jump in and debate stuff?
That's a hard question. I feel we are being held back by our day jobs. Whenever I look at what I'm doing, the core guidelines work comes up very high near the top. It's the one that addresses the complexity. It's the one that addresses learning. It's the one that addresses where the weak points are for future things. And then I find in a normal working week, I don't have time to do all the work. If you look at my list of items I should deal with, that's enormously long and I'm not making progress. How can people help? They can try using the core guidelines. so that they get so that we can get solid feedback rather than random ideas. It's fairly easy to look at the core guidelines and says, I don't like that, or I like that, or we should do that. But experience matters. We don't want everybody's bright idea, not even our own. For you haven't been on these phone calls, but we quite often says, no, this is just our bright idea. We are not going to do that. And so discuss things in public, present experience work, carefully write a note about it, not just these little 2 or 3 line things or 10 line things that you put on the GitHub things. Actually, multi-page arguments with good rationale, good experience feedback.
So before I ask Michael a question about, he's had his hand up and so have Bryce, let me just direct a follow-up, a leading question to you, Bjarne, as a follow-up. Can people help the core guidelines by encouraging their companies to adopt them?
Yes.
Should they? Can you give just a tip or two on how they can accomplish this?
Okay. You can't just absorb the whole core guideline at once. What we need for easier support of the core guidelines is wider availability of static analyzers that support them. Microsoft is slugging along in that area. I really would like to say that on every system, you can guarantee that there's no dangling pointers. If you follow just the key core guidelines things, that's what you get. But you can't really do it if your compiler is in a different tool infrastructure than what Microsoft supports. I would like to see it in Clang and in GCC, so I'll encourage people to help those open source projects to get static analyzers that support the core guidelines. Until that
Michael,
happens,
you've been patient, and also Bryce.
We're going to do less than we should. Apart from that, grab the core guidelines, look at them, adopt a few, see how it works, adopt some more based on that experience. Gradual introduction.
Thank you, Michael.
Although Bryce has his hand up for longer, but I'll say my part quickly. I think it's important for us to for the core guideline. I think there's certainly some parts of it that if you're an expert in a particular area, that's the area to focus on. So in my talk yesterday on safe concurrency of C++ parallel guidelines, I compared core guidelines and contributions from various other sources. And I noticed that particular area is particularly thin. And that's not the fault of the editors. It's because there are not that many concurrency experts. So I've been working on a project for the last 2 years to try to strengthen and improve that area through MISRA. And then and coming out of that, also feeding back to the core guidelines. So that's one point. Second point is, I totally agree with Bjarne in terms of the static analyzers. If you can get more specific rules in the core guide. So right now, core guidelines have but some that are meta rules, which are hard, which are not decidable easily, and some rules that are decidable, which means that you can actually statically check them. The more statically checkable rules there are, not to say that meta rules are not useful, they are, the more you'll be able to involve people like Coverity, Synopsys, LDRA, Perforce to be able to generate tools for the core guidelines, in addition to well-known ones like Microsoft, Red Hat, as well as Clang. Thanks. So I'll defer to Bryce now. Thanks.
Yeah, we have quite a few questions, but Bryce, you've been in the queue. Go. We'll take you, and then we'll take more questions.
So I think a lot of what we've just said about not only the logging question, but the core guidelines touches on what I think is the most important innovation in our process that we've had in recent years, which is we have in the past few years, the past 1 or 2 years really, gotten a lot better about having priorities and explicit plans for what the committee is going to be doing. We didn't always have that. And in the earlier days, I think that was perfectly fine. But as the committee grew in size, that meant that we also had a lot more stakeholders present, and we had a lot more people we had a lot more ideas about what we should be focusing on. And it reached a point where we had a lack of focus. And fortunately, Bjarne and a few others pointed out this problem, and we took some steps to address it. And I think that the greatest of those was that for C++ 17 for C++ 20 and for C++ 23, we had an explicitly written up plan of what our main objectives were going to be, what main features we were going to pursue. We are doing, and I think that having that plan makes it a lot easier for us to execute on it. So I consider myself very lucky as a chair to have very clear guidance from the committee about what our priorities should be for C++ 23, because that helps me express to my working group what we should be focusing on.
Yeah, and we should definitely give a shout out to Ville Voutilainen, who drove creating that document and getting consensus on it through the committee. So it's been very helpful. Now, this next question is that the core language is becoming bigger and more complicated with each release. How do you plan to simplify the language? Perhaps that includes the question, do you plan to simplify the language? But there is a how there. Bjarne?
You can't. There's so much code out there that whatever we change, whatever we stop from working, we have 100,000 or 1 million people screaming at us. People always want three things. They want a smaller language, they want a couple of extra features, and they want us not to break their code. We cannot simplify the language. What we can do is simplify the use of the language. We can modernize education, focusing on what is easy to get started with and what is genuinely useful today. And then we can use core guidelines backed by static analysis to enforce a simpler usage pattern. I mean, the core guidelines are not random, separated from my ideas of language evolution.
Right. And I noticed several of you nodding there. Inbol, Michael?
If I might, yeah, is that you don't need to learn all of C++ to do something useful. And indeed, I'm hoping that JF is in the education group is going to go through certain ways of showing how certain sets of C++ can be useful enough for doing reasonable tasks. We're not saying we need to subset the language, but from an education point of view, you can develop a reasonable roadmap that allows you to do something useful. Thank you.
I would love to add just my view that I think that simplicity shouldn't be a goal for the sake of education, but it should be explicit. It should be a language that allows you to explicitly express what you want, and that would be useful both for developers that work 20 years and for new ones. And besides from that, I agree that some kind of a guideline would be great for making this clearer for educators. So, thank you.
Sorry, would it make sense to delay C++ 23 into C++ 24 due to the whole calamity of this year? Perhaps someone who hasn't commented lately.
Herb, I'll just comment quickly. I think, no, we absolutely shouldn't do that. The thing that I believe has the strongest consensus on the committee is that the schedule is a good thing. Yes. That we ship on time. We have a model where we don't have feature-centric releases. We ship on a schedule. So we'll ship a standard in C++ 23 with the things that are ready.
actually think too that we just did a giant release. Like C++20 is too big to fit in my brain right now. It's kind of nice that we maybe do some little things and fix up some stuff. And overall, I just want to mention, like, we're kind of lucky. We're lucky people on the call. People that are at the conference. We're in an industry that, for the most part, we can work from home, more stable than a lot of other jobs. And it's still yet it's affecting us even. Like, you know, I'm depressed. I don't know everyone else. You know, like it's not simple. So it is going to affect the committee. I've been to hardly any committee online meetings because, you know, trying to live through the next day. So, you know, maybe C++23 will be slightly different than what we expected, but I still expect there'll be good things. And I think it'll be a good chance to take some time and do things right. So it might work out well.
I don't think that we should let it change our plans. It might change how we execute on those plans, because we have to be mindful of not only the change of the environments, but also, you know, we have to put the both physical and mental health of our participants first.
Yeah. So to Tony, I heard a beautiful quote from a friend of mine. He says, "So computer scientists are naturally socially distanced anyway." So I don't know if C++ is going to affect our plans a great deal.
I need to see people face to face and with a whiteboard. Otherwise, I become very ineffective and I risk being in a bubble. Apart from that, we should stick to schedule. We have a plan. We can execute on the plan. Given the search, we can't do as much, in my opinion, as we could have done before. We should be very happy if we got one of the major issues. And after C++ 11, which was a major move, we got 14 that handles the things we couldn't get into 11 and things we only learned after 11 was out. I think that 23 could be something very similar than 14 in that sense, and we should be very happy. 14 polished the corners and completed 11. Maybe 23 will do that for 20.
Yes. Now, let me just jump in with an observation that you made, Bjarne, that C++20 is the third time that we've shipped a major standard upgrade, in our history. And it's the first time I heard you say in Prague that C++ has, with the exception of uniform function call, has every single feature that you described in the design and evolution of C++ back in 1994. Design and Evolution of C++. I don't know if anybody has seen that book. Anybody have? Oh, that's it there.
And I think I have it as well. Tony, that's your copy though that you loaned me, so I could give it to you. Yeah.
All right. Thanks.
Well, you should share that, Tony. Don't hog it to yourself.
Right.
Does anyone else need it?
I think
Inbol doesn't have a copy, right?
Such a smooth handover was a bit difficult.
Yeah. Inbol, do you want a copy? Yeah.
And by the way, the follow-up to C++, to the didnt, the late history paper is roughly the second volume that people have asked for.
Tony, send it to me, please.
We're having fun with didnt after all these years, Bjarne.
Wow, and I don't have a copy handy.
So here is another question that sounds a lot like one we just had, but this is a brand new question that is the currently highest upvoted question, which means I think that they weren't satisfied with your answers. So it's those who didn't comment on the first one, perhaps you can weigh in. The follow-up is, at some point, is breaking backward compatibility the only way to truly simplify the language or change some of the wrong defaults? That's the current upvoted question, which has come in since the last discussion on simplification. It seems people aren't satisfied yet. Tony?
I don't know if this quite answers the question, but I've had this, there's been a few things in the language that people are like, oh, we can never change that. Like we can never change how we initialize or don't initialize integers, or we can never change that functions are mutable by default instead of being const by default, or explicit, constructors are implicit instead of explicit by default. We can change all these things, but I think for any change like that, especially something where we want to go from A to not A, to go to the exact opposite, it's slightly easier if we just want to stop doing something. If we want to stop doing auto pointer, that can take 5 or 10 years. If we want to actually switch, make all constructors explicit unless you said implicit, there's a path for that. It's just a 20-year path. Like first you would have to introduce the implicit keyword. You say, yeah, there's explicit and there's also the implicit keyword, and that's all you do. That's just one release. Then the next release, or maybe even 2 releases, you say you have to use one of these words, and you don't have to, but the compiler starts warning that, hey, you didn't say explicit or implicit. You should really specify, and maybe it's a core guideline at first, and then eventually you turn on at some point we say, you must say implicit or explicit. But this has been like 10 or 15 years, because if we turn that on too early, everyone would be screaming at us that nothing compiles. Give people lots of time to do it. And then eventually you say, you don't need to say explicit anymore. It switches to the default. But there was a path, and that path took at least 20 years to get to. Like 20 years, I might not be programming anymore. But I would gladly work towards on things that take 20 years to do in the committee, if that helps the next generation of developers.
Jay?
It took 20 years for Sun to not have to support ARM compatibility. That's not even a standard. This was what I did in '88. This is very, very hard. People underestimate what it takes. They say, I can do it for my code, I can do it for my company, but it doesn't really matter if you can do it for your company. There will be 1 million people that are doing something else. And furthermore, we can't get agreement on what it is that needs to go if it's major. If it's minor, it doesn't matter. Then we're just fiddling with details. But take a major issue and change it from X to non-X. I don't see it happening. This is what you have to live with a successful language.
JF for Hana?
Yeah, I think there's certain types of issues that are easier than others. And as Bjarne was saying, like the smaller ones in often cases are easier, because what we can do is use tooling to help us in a lot of cases, right? And have developers opt in to what they want to change, right? So for example, in the last years, a bit more, I've worked on improving security of particular code bases, and that's a fully opt-in thing. And we modified the compiler, static analysis, using better guidelines, as well as using better diagnostics, and then having the compiler do more things that you want to improve the security of your code base. But that's purely opt-in, right? Like the difficulty really comes in when the standard says this is what you must do, right? That's why having guidelines is such a powerful thing, if we all agree on what those guidelines are, because that's purely opt-in. If you decide I want better security, therefore I'm going to follow these guidelines, or I want fewer gotchas in my code, I'll follow these guidelines. You do it at your own pace, right? There are certain code bases that people cannot touch for particular reasons, right? Like if you're certifying your code, you can't touch it, right? Like there's a typo, who cares? You're not going to change the code and recertify it for a typo, or because it's hard to read, right? Like it's already been certified, it works well for the last 20 years. And so I think we have to be really careful in how we change things. I think it's important to change things for the better, and tooling is really the key here. And we have to do it really mindfully of what developers want as well, right? I think it's useful to do these big experiments as kind of side parts of C++, where we have tooling helping us see, if I do this, does it work? It worked in this code base, is it going to work in other code bases? I think that's really key, really understanding what that looks like.
I would like
Sorry.
That's okay. I just wanted to add to Jeff's line of thought and say that I think it needs to be understood that programming language is a way to express for the developer to express will for the compiler and eventually to get to the machine. So I think it's also important to identify which features we would like the tooling to have the decision of, and which ones we think that it's something that the developer needs to express in the code. So that's like doing everything automatically is very good for certain things, but we just need to make sure that we identify the rights. That's what
I don't have exact answer for like how to fix to be able to break things, but there are things which can be which cannot be break because, and you can in committee we cannot change them because they are on the implementation decision of implementers. You can see on strategies, obviously, my favorite topic. Design is sound, but the implementation is implemented in some way, and if we change it, we will break API compatibility, and we cannot do it, and we cannot do it with most of the things, and it's up to implementers to decide. But do you remember string at GCC API fiasco? I would say it still haunts me.
Thank you all. Now, our next question, there's actually two questions side by side, which are almost identical, and combined, they have the highest upvotes. How do I get involved in the ISO C++ committee? As someone who's never participated before, how do I begin getting involved?
So that is currently a little bit tricky because normally the guidance that we give people is to, you can come to one of the face-to-face meetings, and that's a good way to get initiated, but those aren't happening right now. So I think the best way to get involved is the way that I originally got involved, which is before I was on the committee, I was aware of the committee and I was aware of the committee papers, and there was one particular paper on multidimensional arrays that was of interest to me. It was in the domain that I worked in. So I contacted the paper author, and I gave him some of my thoughts about and feedback on his paper, suggestions for how he might improve it, some typo fixes, stuff like that. And out of that interaction with him, I got involved in the committee, and then eventually he said, "Hey, you should go to one of the face-to-face meetings." So I think that's probably the best way for you to get involved, is not to get involved in general, but to find a particular thing that the committee is working on that you believe is important or that you have feedback or comments on. And all of the papers have the authors listed and contact information for those authors. So you can reach out to those authors and give them your input. And I think you'll find that the majority of proposal authors are going to be very excited to get feedback from people. That's often the one thing that can be hard to get.
So Herb, I will add that SG14 and by extension SG19 is one of the prototypical outreach groups, and we often get people who are not normally officially represented and in the committee through the national body or whatever, so that they can participate, and in so doing, they can join author papers, as Bryce said, and if they can't attend committee meetings or call in, they are being proxied by some of the more experienced members of those groups. Now, they're not the only outreach groups anymore. There are other groups that are just as outreach. So that is a way to get in, even if you're not registered as a national body. But otherwise, the way, because it's an ISO, you kind of have to be, national body or whatever. But I think that Herb has made it fairly relaxed in that almost anybody, in the spirit of openness, to allow almost anybody to participate with just some notice. So in that way, I think we're trying to be as open as possible. And there are many different avenues to allow us to do that.
Yes, and I would like to add to that, Michael, that the same is true for SG20. And especially in SG20, it is fairly easy to do that because we want to write these small descriptions of what are guidelines for teaching this specific topic. And people who have experience in teaching that, they could write those guidelines. You don't have to know all about all of these things, all of C++, just how do I teach this? So yes, please participate. And it's we have a mailing list that you can just join.
And the decoder ring for SG20 is that's for teaching?
SG20 is for teaching, yes.
Yes, because some of the SGs were mentioned real quick. And, related to that, the current top voted question, and perhaps we can finish on that, you mentioned having examples. It asks, is there a site that shows examples of each new C++ feature using a compiler explorer link? And should there be?
So I think CPP reference does a really good job of outlining some of the features and has really good examples. And it's a wiki, so I wouldn't go and just edit all of it to have links to Godbolt, right? But like suggesting in the CPP reference kind of talk
and they
pages,
also have,
like, hey, could we do this? I think would be really cool.
Sorry. And they also have snippets that you can run, and I think that's very expressive. So.
For C++ 17, I did on my GitHub page, there's a C++ 17 every feature in a Tony table. That's why they're called Tony tables. I started to do it for 20, and 20 is just gigantic. So if anybody wants to add the list for 20, but I actually agree with let's just do it all in CPP reference. They already have some of their examples can already link to Godbolt, so let's go for it. Let's do it.
Examples are great, but too many people get hooked on trying to learn all the features and all the aspects of the features. Really try not to do that. Look at the concepts, look at how the language as a whole addresses things. This is one of the things where books and longer articles beats the simple answer from CPP reference or somewhere else. I use CPP reference all the time because I have to look up all of these little details I've forgotten. But try and learn the language as a whole. Try and learn it as a modern language, not as C with a few weird extensions, as some people are still taught.
Thank you. JF or Inbol, I see you nodding.
I'll just add that this really relates to what I said earlier, and I think it's important to have a broad understanding of the environment, and because especially with people that start that are new to the language, and so I think it's really important to have a strong base to comprehend the language.
Thank you. Now, we have about 2 minutes left. Let's have one quick round, and let me throw in a question that touches on some of the ones said, but just as a nice closer. What are you most excited about? Why are you excited about C++ over the next few years? What do you look forward to?
For me, it's mostly better context pair. Having containers in context pair and ability to do anything in context pair, almost anything.
I'll say for me, it's going to be hoping to improve C++ for more embedded support, safety, and machine learning.
For me, it'll be cleaning up things with modules and concepts. And then I've been missing coroutines forever. So it'll take me a few years to really digest C++ 20.
I look forward to easier C++ through higher level abstractions without getting away from the low level hardware access. Write what you mean, not how you want it done.
I think that a lot of the work that we're doing on executors and asynchronous I/O is really going to revolutionize the standard library and let us modernize it over the next 10 years. And likewise, I think a lot of our efforts on tooling and modules are going to enable sort of diverse package ecosystems that we need to make third-party libraries much more accessible to users.
I would love to jump in. I think that C++20 by itself is a very powerful toolbox. And I'm really looking forward to see how people would use that. And especially, again, since I'm coming from embedded, I think that we're going to see a lot of almost a paradigm shift when using concepts. And I'm looking forward to it.
I'm looking forward to making the language easier to use and harder to misuse, and especially trying to improve things in the area of security, reliability, safety, and doing that without compromising on the performance aspect of stuff, right? So when you want to dive deep and have high performance, I want you to be able to do that, right? Like have that section that's really well tuned, but the rest, like I don't want sharp edges everywhere, right? I want it to be easy to use well. That's what I'm excited about.
Everyone said such smart things, so I'm just going to say I'm looking forward to everyone finding the new rhymes in C++20. Please go read the standard.
Thank you, and thank you all for taking time. I know that we today had panelists from 3 different continents live, so in whatever time zone you're in as panelists, and the hundreds of you who are online live right now, wherever time zone that you're in, I hope you enjoyed this hour. We had some more questions than we could get to, but we got to quite a few. And I really appreciate the insightful answers and the different perspectives that we got from our panelists. Now, as we head into the regular program for day 2 of CppCon, I hope you enjoy the rest of the day as we continue our week together. Thank you for attending and enjoy the rest of your day.